Greetings, this is lesson 2.5, proving statements. Go ahead and get started. We're going to go ahead and complete some more two-column proofs here as we continue this, utilizing some of the properties, postulates, definitions, theorems to show why something is true. So let's draw a few angles here. We're going to draw angles 1 and 2, which are acute angles, and then angle 3, which is an obtuse angle. And what our given is here is that, well, just a second here, guys. Let me get my chat fixed here. So I can interact here, see if I have anybody to shout out here. Nobody's chiming in yet. Okay. We have our given, which is that angle 1 is supplementary to angle 3. And angle 2 is supplementary to angle 3. And what we're going to prove is that angle 1 and angle 2 have the relationship of being congruent. Right. Here we go. So, on the left, we have our statements column. And on the right, we have our reasons column. Now remember, on the left, we state the what in explainer work, and on the right, we explain the why. I'm sorry, on the left, we explain the what as we show our work, and on the right, we explain the why, and we explain it. So show it and explain it, what and why. And our whys are always going to be very succinct and direct answers that will be a definition, postulate, property, or theorem. First one, we'll start effectively the same way. So we enumerate these, and we'll have angle 1, and I'm going to abbreviate a little bit. I'm going to abbreviate supplementary to angle 3, and we have angle 2 is supplementary to angle 3. And this is because this is given. Number 2. If something is supplementary, what that means is that it means the sum of those two angles equals 180 degrees. So angle 1 plus angle 3 is 180, and angle 2 plus angle 3 is equal to 180. Now, what we're demonstrating here is a definition that we have, right? This is not angle addition, right? I know that we're adding angles technically. Angle 1 and angle 3 are being added. But what's really happening here, or angle addition is when we do this, right? When we have angles and they're adjacent, right? They share this side, and then we can create a greater aggregate angle by combining them. That's not what we're doing here. Instead, we're actually defining these. The reason they equal 180 is because it said that they're supplementary, right? And supplementary angles have a sum of 180. So this is definition of supplementary angles. So we're fulfilling this by stating the definition. Okay, so the first thing was given. Now we're giving a definition. Definitions, properties, postulates, and theorems go on the right side. So then we have the measurement of angle 1 plus the measurement of angle 2. I'm sorry, we can just say angle 1. That's where we're at. Plus the angle 3 is equal to angle 1. Sorry, guys, I'm really struggling here. Angle 2 plus angle 3. And the reason that is because both things are equal to 180, so they equal each other. This is that whole thing of A equals B and B equals C, then A equals C, and that is the transitive property. All right. Now, since both things, 1 and 2, have 3 added onto them, right? I'm trying to prove here. This is my whole point of my proof, is this should be my last statement here, okay? When that's my last statement, I have accomplished my proof, and my problem is done. So, I've done it. Angle 1 is congruent to angle 2, okay? And the reason that they're congruent to each other is through subtraction. Now, I'm going to show you guys something real quick. Your textbook has the following. Now, we've used equality and congruence, and we've used them actually interchangeably here. Now, I just subtracted off this angle 3 from both sides. We just did this in today's exercises. And then now, through all these reasons, I have the exact identical statement that I have for the proof statement. I've accomplished my task. Okay, so this is my proof. I'm going to show you guys that there's something in the textbook which is called the definition of congruence. All right, we will not use this. It's saying that the measure of angle 1, when it's equal to the measure of angle 2, that angle 1 is congruent to angle 2. Now, gentlemen, this is what I want to show you, okay? You will not use this. You're never going to cite this in our course. And here's why. I found over the years this was really confusing to students. And then, moreover, what students would do is they just use this definition of congruence like it's a magic trick. Like, boom, I need a definition of congruence. So this is why they're congruent. You can't just magically decide things are congruent just because you want them to be. All right. It just means it's a notation issue. What I should have here, and I'll show you guys. A additional step here. I'm gonna move this guy. Right. Let's move U subtraction down here. Oops. Oh, it didn't take the U with it. That's interesting. Okay. And actually, I'm sorry. My subtraction should have stayed there. Let's go back here. Guys, I'm really struggling here with the with my pen. Okay, so it's this one right here. This guy's gonna get moved down here. Okay. And what I really should have here is that these are all measurements. So what I should have is that the measure of angle 1 is equal to the measure of angle 3. Right, and these are all measurements. Measure, because the measure of 1 and the measure of 3 is equal to 180, the measure and the measure. Okay, that's what that means. And we're going to go from the notation where the measure is equal to the angle is congruent. And then this one, of course, we did through subtraction. And then to get here. And then this is your definition of congruence. Okay. I never use this because I think it's more confusing. I'm fine with you guys interchangeably using congruence and equality. All right. Let's take a couple properties here and just name them. All right. And then we'll do some more proofs. Okay. Name the property. So I have angle A. It's congruent to angle A. What property is that? This is reflexive. How about if I have PQ congruent to JG and JG congruent to XY, then PQ is congruent to XY. Three things each used twice. Looks like a syllogism, but the property is, this is the transitive property. All right. Last but not least, for our exercises today in our notes, but one more proof. Trying to, it's kind of a sloppily drawn angle here. My apologies. You guys can do a little bit better here. This is L, M, N, P. And what's given here is that we have ray MP, which bisects angle LMN. And what we're going to prove, and when our problem is done, is when we have that 2 times angle LMP is equal to the measurement of angle LMN. Okay, so here we go. My two columns. The left is my statements. The right is my reasons. And of course, we start these the same way and restate this, which was given to us. MP bisects angle LMN, and this was given. Number two, we are going to show that we have this angle and this angle are going to be congruent. Angle LMP is congruent to PMN. And the reason why is because we were told that MP is the bisector, so is the definition of bisector. It creates two congruent angles. Okay? Some people just think, oh yeah, bisects because it creates two angles. No, no, no. They have to be congruent. Okay? Next, what I can show is that we can create angle LMN through the sum of LMP and PMN. This is angle addition, right? Two adjacent angles. And this is the angle addition postulate, right? These two angles, that are adjacent, they share that side. Angle plus angle equals a greater angle. Then I have PMN. Remember, PMN is the same as LMP. So what I can do is I can say that angle LMP plus angle. And I can say the measurement of it, right? We can just use these interchangeably. Because I know that this and this are going to be the same because of this statement. Statement number 2 is angle LMN, and that is substitution. And then last but not least, number 5, LMP plus LMP is 2 times the measure of angle LMP. It's equal to LMN. And that is through addition. Also, technically, you could also say this is distributive. You could make an argument for the distributive property if you'd like here. Both were acceptable answers. All right. We'll talk about this more in class about how we can kind of see our way through to the end of these proofs. Sometimes we have to just talk these things out and then just to understand what properties we're going to wind up utilizing. It's all tools that we already have. We just need to know how to operate them. Okay, you have these tools at your disposal, and now we're just going to train you up and get some practice on using them. All right, see you in class.